It's Andrew Engineer. All right, so today we are going to continue our lesson on the modeling, analysis, and dimensioning of a residential building G plus 4. So, in the last lesson, we ended with the load combination. So, now we are going to the load application, and we are going to start with the application of the wall load. Okay, in the last inventory, I did not put the load rule, so I have to edit and start it back to make sure my load rule was there because I forgot. That's why I told you it's very important to know how to make the load inventory in other words. So in order to continue this lesson, I would like to encourage you to subscribe to our channel, and more particularly to our YouTube channel, where all these lessons are being uploaded in times. Okay, so we are going to start with the application of the load, wall load. Okay, so make sure that the load that you are going to apply is being selected up here. Okay, in this bar. Now you come right down here on load definition, you click on it. The wall load is a load apply on member, so you click on member here. Okay, and then you choose the uniform distributed load. Okay, for our walls. Okay, there are many type of load depending on the shape of the wall that you want to apply, because we have those edges at the when you look, for example, at the roof pitch, where they usually be block and it goes up like a triangle. There you can decide maybe to apply this other form, trapezoidal load or triangular load. Okay, so now click on uniform distributed load. You choose the Z component. You make sure that you are on Z component. Then from there, now you have to ask yourself, what is the value of the load that you are going to enter there? And to answer that question, you have to understand that it will raise up many other questions, like what is the thickness of the wall? By the thickness of the wall, we mean the size of the block. Is it block 15? Is it block 12? Is it block 20? Is it block 10? That's a standard size of block in Cameroon. I don't know about your own country. And then after it, what is actually is your wall going to be plaster? If yes, what is the thickness of the plaster? 1.5, 2.5, depending on you. All right, so is your wall going to carry tiles? If yes, what is the thickness of the tiles, and what is the thickness of the mortar used to put the tiles? All right, these are the questions that you have to know in order to know what is the final value of the load that you will apply as a wall load. Okay, so to go about it, we will directly go on the formwork plan. First of all, have a look to our formwork plan. Remember, this formwork plan I just draw it randomly. I did not have the time to like give it a real partition or a distribution plan. So because the distribution plan is actually needed to know in order where walls are going to pass and where there are no walls. Because for example, if you come here, maybe this place here, or let's say this place in front of our staircase here, does not carry actually a wall. All right, so if it doesn't carry a wall, when you will be applying the wall load, you are not supposed to apply the wall load on this beam, on the span CD, for example. So these are the detail where you need in order to know where to apply your type of load. So in order, we are going to take all this corridor like this three from 1 to 4. All right, has a bedroom, has bedroom part. All right, and then here from 3 meter 20. Okay, from this 4 to 5 till down here. All right, till B. Let's say from E to B is a corridor. All right, the same here from the span DC. Okay, it's also a corridor. All right, since it's in front of our staircase. And here we consider BA, this span like this tree, okay, to be our veranda. All right, and here same thing, we consider this three part like bedroom, okay, or dwelling. All right, the staircase of here is equation. So we have this place like this place like this, which form almost a U. All right, to be considered as our circulation. These are our consideration for the work. So now we can go back on our Excel sheet to see how to get the value of that load. So as I said, we have to make in order the inventory of load. So we'll come here under block. We will be looking for block. Remember, we are using the norm Frances NPA 06004 from Bael. All right, so depending on your country, you might be using Indian norm, or let's say Moroccan norm, or British standard norm, or Eurocode. All right, so these are the norm française NPA 0604 that we are going to use for the load inventory. So we are going to look about walls. Okay, here you can see we have different size of block 10, block 15, block 20. All right, with their unit weight, okay, in kilonewton per meter square normally. So let's scroll down. Okay, wall. Okay, that's wall inventory. Okay, here you can see that we first of all have to define what is the height of the wall. Okay, know the height of the wall. For example, for our project is 3.2 normally, and then you have the unit weight according to the size of the block. As you can see, block 15 for the norm française NPA 06004 is actually 1.79 kilonewton per meter square, which are going to be multiplied directly by the height of the wall in order to come back in kilonewton per meter, because it's a linear load. All right, so because we apply it as a linear load. All right, so now the plaster, we I just made the inventory block, plaster, mortar, tiles. I just assume that in this case my wall is gonna carry all this in order to like overload our structure, because most people in Cameroon particularly, they are African, they are not actually sometimes serious. They will tell you, okay, build my house like this, like this, like this, don't put tiles, and then after some time when you are along the process of executing, you hear her speaking something like, no, my brother put his own bill, don't have, he put tiles, please, I would like to have the same color of tiles. And then maybe you are already at a certain level of the project, and then you decide, for example, to like it cannot go. Actually, you tell her that it cannot go. So at times you have to anticipate on the behavior of your client. Though the thickness of my tiles that I consider are not that big, it's just 1 centimeter thickness, as you can see here. Okay, tiles on wall. Let me look for tiles on wall. Tiles on wall. Okay, that's 1 centimeter with their unit load, which is 0.15 kilonewton. So when you have all these detail for the block, the plaster, the mortar, all right, you can see the plaster, I do put 5 centimeter thickness because I consider the both side of the wall. All right, and then the mortar now is 1 centimeter, because I consider that I will put tiles on my wall only on the external wall. Okay, and then same thing with the ties. Here was mortar, so same thing with the ties. Okay, so when you have all this, you simply multiply the block the height of the wall times the unit weight of one block, and then you have this value. Then you just sum all of them all through, and then you have 6.998 or 6.988 kilonewton per meter, which is the value of the load that you are going actually to apply in robot as the wall load. Okay, so we'll go back into robot. We'll come here. Now what you have to understand is that it's a vertical load, but you have to apply it as a negative value, so negative 6.988. all right, so this is it. You click on add. Once it's done, you come here. Let me put the cross section to be visible. Okay, so that we can apply our load without too much stress. So we said here is a veranda, but here we have load. Okay, so this is how we are going to apply the wall load. You can also select all your beam one time if wall are passing all through. So to not to keep the video for so long, we'll continue in the next lesson. Okay, thank you very much. This was NGU. Don't forget to subscribe to our channel in order to encourage us to continue, because this is free knowledge. All right, thank you.